iLabs. This presentation was made in collaboration with my colleague Hardison, and the paper was written with other faculty from the MIT iLabs team and also our partners in Africa. So let me start by saying, what are iLabs? So iLabs are remote laboratories that allow students to run actual experiments on real hardware via the web. So they can be away from the lab, they can be in their dorm rooms and run the lab. And this has a lot of advantages over traditional labs. Some of them are students can run them from anywhere at any time. Other advantages are the sharing is very easy, so the cost per user goes down tremendously. And also the logistics and administrative costs are lower because of the remote use. So the MIT iLabs team since 2002 has developed a standardized framework, a software framework that allows easy development and management of remote labs. So this is a software architecture that allows hardware equipment to be easily plugged in and used remotely. The architecture, the iLabs architecture, has three components. The first one is the lab server. So the lab server is the actual computer that's connected to the hardware equipment. So this has device-specific drivers, the specific instructions for that equipment. And this is usually located very close to the piece of hardware, and that's the lab server. The next piece is the client. This is the interface that the student will use to access the lab. So it provides a graphical representation of the equipment and the experiment set up on the board, on the equipment connected to the lab server, and students can specify parameters and also view the experimental results. The last one, I think the crucial part of the iLabs architecture is the service broker. This is the intermediary between the client and the lab server. So the service broker serves the client to the student. So the student will have an account on the service broker. He would log in, and the service broker will manage the student accounts. It will give permissions to students to the appropriate labs, and the student will say, okay, I have access to this lab, and he can choose a lab and launch the client and run the experiment on the hardware. It's also where all the records and experiment records are stored. So this architecture is open source. It's free for anyone to go on the web, download it, and this allows, it's a really scalable architecture. It really allows institutions to share their hardware very easily with other institutions all over the world. So since iLabs started around 1998, there have been many iLabs developed in various engineering and science disciplines. Some of the most interesting and most important ones are shown here. One of them is the microelectronics device characterization experiment. So this uses a $50,000 piece of equipment hosted at MIT, and students can all over the world have used it to run IV characteristics of devices. Another one which is really interesting is the neutron spectrometer, and this one and other nuclear experiments allow students to run experiments at the MIT nuclear reactor, which is dangerous and it's close to access. So doing it remotely is the ideal way of doing it. Another one which is also interesting is the inverted pendulum one. This one was developed at the University of Queensland in Australia, and it allows students to balance an inverted pendulum, and results show that students were really engaged with that experiment. So in 2005, MIT established a crucial partnership with universities in Africa, Makerere, UDSM, and OAU, and the aim of this partnership was to increase access to science and engineering laboratories to sub-Saharan Africa. Initially, this partnership allowed these universities, the students in these universities, to use some of these experiments here, some of the experiments housed at MIT. So one of them was the microelectronics characterization laboratory. About 600 students have used from Africa have used this experiment so far. However, one of the main limitations was that internet connectivity in these countries is very limited. Bandwidth is expensive, connections are high latency. So the user experience